what's up everyone? This is Will with Origami Cybertruck. Today I just wanted to do kind of a, I don't know, something a little different, kind of a weird little deep dive into laser cutting the tabs on the new tabless electrode batteries from Tesla, the 4680 cells that were debuted at the Battery Investor Day just a little while ago. So I've seen some people kind of wondering about how these things are actually put together, and I think a lot of it was that, you know, Tesla did a really great job of showing how they were, you know, really optimizing the manufacturing process. It's not like there were these necessarily all that many incredible technological breakthroughs so much from a, you know, maybe a chemistry standpoint, though there were some of those as well. For more on that, I definitely recommend checking out the Limiting Factor YouTube channel, which I will link in the description below. But a big emphasis was also on the actual manufacturing of how to do these, because that's really how we're going to get to the scale and drive down the cost of production. So I just wanted to talk a little bit about a subcomponent of this, which I think there's a lot of curiosity out there about. So it's how do they make these, all these little tabs. Now these are called a tabless battery, but in truth, they're kind of a many tabs battery. You could look at it that way. Whereas previously, in a lithium-ion battery, you might have this roll here, which contains all of your battery materials, basically, without going into too much detail about it. You'd have one tab from the very end of the battery from one side, and then on the other side, you'd have another tab from the other end of the battery. The big advantage to having this tabless design here is that it allows you to make much larger batteries, because basically the current doesn't have to flow around and around the spiral to get out. It can now just come from one end of the battery directly to any one of these tabs, wherever it's closest to. That's going to dramatically reduce the internal resistance, which is a great thing to have for your battery. Anyway, but the question was, how are they making all these tabs? Okay, well, I had some thoughts about it. Off camera, I did some measurements in Photoshop. Basically, from here to here is the 46 millimeter size. If you kind of look at across here, that length of that cut, it's about 5 millimeters, plus or minus. So I think the way they're doing this is they're cutting it with a laser in a continuous process. And I have some theories about how they might do this. Now, I'm not an industrial engineer, so this is just my kind of guess at how I might do it if I were trying to make this in a incredibly fast and continuous process, which is very important for this, because we don't want any stops in the production line, because stops in the production line equal inefficiency. Okay, what immediately came to my mind was this. And what this is a supermarket scanner. You've all used them and seen them. Basically, it has a small laser, which this is from EEV blog, another great YouTube channel that I'll link in the description for this particular video. But
to adjust there so they can tweak the.
All right, so basically there's a little laser diode here. Now in our case, this wouldn't be a little laser diode, this would actually be a cutting laser. And then over here, you have all of these mirrors that bounce the light around, and then inside here, let's see if we scroll forward a little.
And then scan
there we go.
So we can actually power that up and watch this.
So that mirror, the diode shoots this way, it bounces back here, this scans, and as this thing turns, it draws a laser line across a surface, in this case to read a barcode, not to cut copper foil. But, you know, basically you can produce this,
very bright at all, but
you can kind of produce that pattern however you need to. Now in our case, we're not interested in producing a bunch of cross hatchings here. We're only interested in producing a straight line repeatedly. But I think that probably what they're doing is they probably have a fiber cutting laser, which is pulsing the laser on and off, I would guess, to actually cut as it passes by each time as the roll is pulled through the process. Now, some questions were, you know, basically laser cutting, isn't that kind of time intensive? And the answer is no, not at all. And here's why. Okay, so I don't know exactly how thick this copper electrode material is, but according to this article that I found, it seemed within reason that it's about 70 micrometers. And so what is 70 micrometers? Okay, that's 0.07 millimeters, so it's almost 0.1 millimeters. If we go to this other web page, which is all about laser feed cutting rates, we see that for copper here, with a 1 millimeter, now remember, that's more than 10 times thicker than our material we're cutting here. With a fiber laser cutting head, a 4 kilowatt head, you can cut 1,700 inches per minute. Again, I'm not a laser cutting expert, but basically it looks like the thinner the material, the faster, like disproportionately faster you can cut. Because see here, you can see this 2 millimeter layer is 591 inches per minute. So by going to half the thickness, you're going way faster, or way more than what, 3 times as fast of a feed you can do. Basically, how many inches or how many distances per minute can you cut? So basically, I think that's how they're doing this. Now, the other question is with regard to these. Now, you'll notice that if you look right here at this corner, it's not a 90-degree angle. All right. Now, I think that it is maybe useful or maybe not necessary for this to be at a non-90-degree angle. But what I think is happening is I think that these things are just rolling by, and as they roll by, the laser head is cutting on an on-axis cut, a 90-degree cut. But as the thing is feeding through, of course, as the laser head is cutting, it's also passing by, and therefore you get this sort of angular cut instead of a perfectly straight 90-degree cut. And so I think that what we're seeing here is an artifact of how they're doing this extremely quickly. So what does this look like? Well, in practice, this would probably look just like a sheet of material going by, a long strip of material going by, with a laser spinning mirror and then a cutting laser located near it, and basically spinning around at the right angle and frequency of this to match or to be synced up with the feed rate of this electrode material passing by the laser. From there, it'll get fed into some sort of bending apparatus that will kind of press these tabs over in a repeated fashion and bend them how you see them here. Here you can see what this may look like in part. Special shout out to 23 Chaos 23 here and Limiting Factor who posted this video earlier. Well, 23 Chaos 23 posted it, and Limiting Factor linked to it, and that's how I saw it. But basically you can see how they're probably going to be bending this up. Now, the cutting process is going to have to happen on this side of it, because as it feeds this way, you're bending those tabs up. But that's how I think that they're doing it. They're cutting probably immediately prior to this and then going directly into the tab bending process, if I were to guess. So anyway, I hope that kind of helps. If anyone had any questions about that, seems to make sense of how to do this in a continuous process way. You don't need to have some sort of really elaborate setup. In fact, it's a very simple setup. It's a highly synchronized and reliable spinning mirror and a laser cutting head. And basically, you're just syncing the two up, cutting it, and there you go. All right, cool. Let me know what you guys think.